Hello friends, welcome back to our YouTube channel Struggle to Satisfaction, and today I am here in front of you to show you how to do routing in piping, or what are the things that you need to understand when you are routing your pipes on the pipe rack. So first of all, let me give you an introduction about pipe rack. What is pipe rack? So pipe rack is a technical structure which used to carry the loads of pipe which is running on the pipe rack as a bundle means like more than two pipes. Okay, and it is going to provide a systematic way of supporting at a particular span. So that's the main purpose of pipe rack. So it is basically taking the loads of pipe which is traveling from one equipment to another equipment within the unit, or within inside the unit or outside the units. Okay, so pipe rack, who creates pipe rack? The question arises, who creates pipe rack? Is it in a piping scope, or is it in a structural scope? So the first thing is that as a piping designer, you are the one who is going to provide information about the location of pipe rack. Now location of pipe rack means the coordinates, obviously. Second thing, that the information that you are going to provide is the width of the pipe rack, height of the pipe rack, and the number of tiers required within the pipe rack, the intermediate levels, and all those information will be provided from the piping side. Anyway, after this, the structural people will do their own calculation, like they will calculate the point loads at every sections, and accordingly they will create the structure. Okay, so basically what is happening, they are going to decide the size of the profiles, like the columns and the beams which they are using it. So they are going to decide the size of the profiles. So as a piping designer, your responsibility is to provide the layout for the pipe rack. Okay, so I already created a pipe rack for you guys. If you wanted to me to create a pipe rack, so just let me know in the comment box. I will show you how I created and how these dimensions are calculated, because definitely before creating any pipe rack you have to do some sort of calculation that belongs to the part of piping layout, okay, or piping design engineering. So that's its part. Okay, so you need to find out the number of pipes running on the pipe rack. Then you need to segregate how many what type of pipes are they, like is it a process pipe or utility pipe, or the flare and the instrument cable trays, what are the things are going to rest on the pipe rack. So you need to decide that. For that you need to study the layout, you need to study the PNID, then calculate the number of lines, then arrange those lines in a systematic manner, future expansion. So everything you need to consider, and then you will come to a conclusion that okay, this is the pipe rack width, these are the number of tiers required, and these are the spans between the two columns. Okay, so that's also a big chunk of part. Okay, but today we are going to show you how to do the routings in the pipe rack. That is important. Okay, so basically what you need to understand is, if you want to route a piping in the pipe rack, the first thing is that how to enter in the pipe rack. Okay, so to enter in the pipe rack, okay, but before, let me show you in the paint. Okay, so if I show you the plan view, so let us assume that this is my pipe rack. Okay, and the pipes are running in this fashion, correct? So the pipes are running in this fashion, and some pipes are like this, some pipes are like this, and some are like this. Okay, something are like this. So is it the correct way of routing a pipe? No, definitely not. So the thing that you need to understand is there should be a what you can say, the spacing between the pipes that you need to consider. Okay, if you don't have any idea about that, so just go to the Pipe Data Pro. I hope you are aware of this software. So go to the Pipe Data Pro. Okay, in this Pipe Data Pro you can see a tab here. This is called pipe spacing, right? So this tab, and from here you can calculate the distance between the center to center dimension, or center to center gap between the two pipes. So from here you need to calculate that what is the size of the pipe and the rating of the pipe and the next pipe, so you can calculate the distance between two. So these all are covered in the piping layout part when we study the pipe rack calculation. Okay, but here suppose for example, if someone asks you to do a piping, okay, from equipment A to equipment B, okay, from equipment A to equipment B. See, learning E3D is not enough to make you expert in piping design. Okay, you need to learn the layout also. So let us say this is, it's a dummy. Okay, it's a dummy layout. So let us say I have an equipment here and I have another equipment here. Correct. I have an equipment here and I have an equipment here, and I need to start my routing. So how you gonna route? You're gonna come here, you're gonna run on the pipe rack. Okay, and this is for what pipe rack we created, like this. So this is a systematic way of routing a pipe rack with a proper supporting on the pipe rack. You can give support here, you can give support here, right? So this is the way of routing a line on the pipe rack. Okay, either you can route like this also straight, you can come like this, or you can come like this without a pipe rail, you can come like this. So this is going to hamper the layout and it doesn't look good also. Okay, so that's why we have a systematic way of routing everything. So that's why we created a pipe rail. Okay, so if a pipe is starting from this point and it is going to this point, how to route it? Okay, so let us assume I have an equipment one at here and one at here. Okay, so let's say let me create one equipment. So here you can see I created two equipment at a certain distance, like one is at this corner and one is at this corner, right? So how to route a pipe if you want to go to from equipment 1 to equipment second, or equipment A to equipment B. So how to route a line in the pipe rack? So for that purpose, what you need to do is you have to be on the zone of piping. Definitely all the pipes is going to store in the piping zone. Then you have to switch on to the piping discipline, and from here you can see a new extra tab is created. Now you have to create a pipe. Okay, so as I am aware that this nozzle is of 4-inch nozzle with a 150 rating of this, so I'm going to create 4-inch dash p pg, let us say pg dash 1500 dash a1 is my spec. Okay, and enter, and then I can choose here a1 a spec, and from here I can choose the bore, right? And then so now let's take this one as a A1 spec, and the bore of this pipe is 100. Okay, because the nozzle size is 4-inch, right? And then just click apply. Once you click apply, you can see here the branch head and the branch tail option is we have here, and your branch one is created here. So let me first connect my branch head to this nozzle, right? So branch head is connected. Now go to the create component. Okay, okay, yeah. So create component form is open right now. Now the first component that you need to select is the gasket, which is going to connect with your nozzle. So 150 mm 150 rating gasket, just click on create. So gasket is created here. The next component will be your flange. So this is my flange, just uncheck this, and yeah, so my flange is created. Now the next component which I am going to create is the elbow 90-degree. Click on create. Now this is in this direction. I need to rotate this one towards south, so I just simply type direction south. It is rotated here. Now the option here is either I will take this up and then go like this, right? I will take this up and go like this, but that is not the way of routing pipe in the pipe rather. What you need to do is, first of all, you have to check the position of this elbow. So q position wrt slash star, q position wrt slash star. So what is the elevation of this elbow? Right now is 2430, which is above your headroom clearance. Okay, so I can go first, I can go straight. Okay, I can go straight, or else the to be precise, if you want to be precise, so check QLBOP. That will show the bottom of the elbow. Basically we need to check the bottom of the elbow itself. So it is more than, it is more than what, it is more than 2.2 meter. Okay, but still what I'm going to do here is I'm going to create a spool in between the elbow and the flange, just for some future changes or something. Will just clear 100 mm spool is given. Now if you check the LBOP, right now it's 2472, more than enough. And then I will create a elbow again. So new elbow, choose all, 90-degree elbow. Okay, then you need to connect it, now this time direction will be up. Okay, this time direction will be up. Now what you need to do is you have to bring this elbow towards here. So I am going to choose through id at the rate enter and just click on this. Okay, once you click on this, the elbow is at the center of this column. But what basically we needed here is the back of the elbow should be 300 mm away from the edge of the column. Okay, so what I'm going to do here is just by moving this one by north, let us say 350 WRT slash star. So right now this is this much. Now if I go to home and I go to measure, graphics, cursor, and then I will try to measure or take the edge of this elbow to the edge of this member. So it is right now 243 mm, correct? So 243 mm means how much? So 300, I need to maintain a 300 minus 243, so 57 mm I need to move this elbow towards north. Okay, so by north 57 WRT slash star enter. So now it is correct, exactly 300 mm. The back, it is called back of the pipe. Okay, it is called back of the pipe. So this back of the pipe is 300 mm. Now you need to create another elbow. So just repeating the same command. So double click on the command elbow, 90-degree, and then just type connect. Now this time the direction will be towards which direction? South. So I will type dir space s. Right now I will, okay, now if you want to, there are two ways. Okay, first way is like either you can go here and take a turn and then you can take this side. So I will show you that also. So through id cursor, click on this, it will come here. Now what you need to do is you need to first of all make the BOP of the pipe should be matching with the top of steel. Okay, so let me measure distance, graphic cursor, you can take this P point and you can take this top, it's 107. Okay, so 107. So what you need to do is buy up 107. So the BOP of the elbow is matching with the top of steel. Now I am going to create one elbow. Okay, so new elbow is created, just click on connect. So it is connected, right? So after this what you need to do is now you need to move this elbow till here. So what I'm going to do, through id cursor, click on this section, it will come here. Now you have to move it inside the column. Okay, so the edge of the, now this time the edge of this elbow should be 100 mm clearance from the edge of this column. Okay, edge of this column, because beam size can be smaller than the column size, so always take the bigger section. So always from the edge of the column, so go to measure and then graphic cursor is already there, take this one and the edge of this column, so that can be your this part. So how much is this, how much is this? 107. So plus 100, so that you need to move this elbow towards south direction by 207. So I will move this elbow so by south 207 WRT slash star enter. So this is gone inside. Okay, one more thing that you need to notice here is this is not done actually. Why? Because see, can you see this weld, this weld? So this weld is coming exactly on the member, exactly on the member. If the weld is coming exactly on the member, what will happen, it will raise the bottom of pipe by certain so always remember that you cannot keep any weld on the steel member because it will raise the elevation of the pipe. So other again by south let us take 50 wrt slash star enter. So what you need to do is now you need to measure. Okay, so the weld and this corner has to maintain a minimum weld spool. Okay, so right now this is 54 only, so that is not sufficient, so I have to maintain it a 100 so what I am going to do is I will move it by south 46. Yeah, so a clear 100 spool is from the edge of the beam to the edge of the weld. Okay, so this is the correct way of routing a pipe here. Now what you can do is you can move this elbow to the end of the pipe rack. Okay, to the end of the pipe rack. So just okay, now you need to do is like in this way. New flange, choose all, and then you to suppose you are going to cancel this one. What happened? Any flange is created or what? Oh, sorry. Okay, delete. I just deleted this one. Click on the elbow, go to the piping component form, click on the flange weld neck, and then you have to just click on create, and after that go to modify, then through id cursor, and then click on this member. Okay, again you can see that the flange weld is coming at the center of the member, so always remember that the flange has to be a certain distance outside, so usually we consider it 300 so by east 300 wrt slash star enter, and then you have to close the branch. So branch connection pipe tail to last member. Okay, so this is how your first branch is going to be closed. So this is one way of routing a pipe if you are routing flat, if you are routing flat. Okay, right, see there is a study, because we used to do study. Okay, this is just I'm just simply telling you the way of routing, but this is basically it is not correct, it is not at all correct. Okay, so in the study what we need to, what we understand is which pipe has to come at the corner, which pipe will have at the center, or what pipe has to be come means what is the position of the pipe in the pipe rack. So that is also a calculation or studies, everything is there, but today we are discussing only the way of routing. So this is one way which is called as flat turn. This is called as flat turn routing. Okay, now the another way of routing the same pipe. So what in that scenario what will happen, this is your member. Okay, this is your member. Okay, now I am going to copy this member. So new box, copy previous by up 1500 enter. Yeah, so this is another member. Now let me show you the correct way. If suppose same pipe has to route in the pipe rack, then what will happen if we are not taking any flat turns, then what will happen? So what we need to do is this pipe, I think this is too much high, so uh, buy down 500 wrt slash star. Okay, there is a calculation for this also, like what will be the intermediate member height. Okay, this is called the intermediate member or intermediate support member. So the calculation of this height is also needed to be done. Okay, so I just click on this elbow and then I just put it by up 1 meter wrt slash star enter. Then I'm going to put it up like next through C. Okay, and then here the only changes is that it is going to be down, so dir down, and then you have to create a new elbow that is called as 90-degree elbow. It is created, then the direction will be east, dir east, and then through next. So this is how you gonna route a pipe in the pipe rack on the first tier, correct? The same thing is going to be routed in the second tier. okay, in the second tier. So again you have to maintain a back of pipe of 300 mm. Okay, so you have a support here, you have a support here, and you have a support here. Okay, now one more thing is that you need to remember is that in the pipe rack you will have a intermediate members. Now this member, this particular or this one, so basically what happened, for example, if this is your pipe rack, so you will have a new box copy previous by east, and this has to be 4 meter. 4 meter means the distance between the two bays. Okay, so again, so this is how actually your pipe rack has to be made. So there is an intermediate member here, so that is also going to be used as a support for the smaller line, because 8 inch and above lines you will require a support at every 8 meter, but below then below 8 inch and below you need a support at a frequent distance. Okay, so 2 inch to 8 inch you need a frequent supporting, even though basically the 2 inch line we usually avoid, or below 2 inch line we never routed in the pipe rack. Okay, so don't route any line which is 2 inch and below in the pipe rack. For them, if you wanted, suppose you have a utility station and all those things, so you can take out the, you can extend the pipe rack cantilever from the pipe rack, and then you can take a bundle of your utility lines together, so that you can take support at every 3 or 4 meters. So you can extend a cantilever from here or somewhere wherever you want it, so you can route in that. But in the main pipe rack, never route lines which is below 2 inch and below. Okay, right. So this is the first way of, second way of routing, correct? Okay, now sometimes what will happen, for example, if you have a wall assembly, so let me create a wall assembly. Okay, so new flange, choose all. I don't know it's working. Yeah, it's working now. So new flange, this one, and then you need to connect. Okay, you need to give a clear spool of, let us say, 500, and then you need a gasket. So new gasket, choose all, sorry, new gasket, choose all, then you have a gasket of 150. Okay, then you need to connect it, then new wall, choose all. Okay, let us assume you have a, okay, let's say gasket, and then go to piping component, wall. Okay, you have a gate wall you created here, and then you have again a gasket. Okay, gasket, connect, and then you will have a flange, and you, oops, sorry, not this one. So go to reselect and change it to weld neck, because that was a slip on flange, right? So it's changed. Okay, so I just added a valve here. Now could you tell me like whether this valve location of valve is correct or not? So whenever you have a valve, only 2-3 things that you need to keep in your mind is like the uh, safety of the valve. Safety of the valve means, like, see, suppose if your pipe is having some hazardous fluid in that, so you should not rotate the handle of the valve below 90 degrees. So this is 0, this side is 90, below is 180, and the other side is 270. So below 90 you cannot rotate your wall, because the wall start leaking from the handle. So that is one point. Second point is that always remember to route a wall in a horizontal line only. Don't try to put wall in a vertical line, it's avoidable, but try to put on the horizontal line. And the third thing that you need to check is the elevation of the wall handle. So let's now check the elevation of the wall handle. If I go here, go to measure graphic cursor, and always check from the center of the wall handle to the bottom of the grade, or to the grade level. So right now it's at 3 meter. So is it possible for a person to reach his hand and operate the wall? So it's not possible. So again you need to do what? You need to change the routing of this. Correct, you need to change the routing of this. Now how you gonna change the routing of this, that you need to understand here is, after this elbow you need to create one more elbow. So this is your elbow. Okay, creating an elbow. Now this time you are going to do the direction down from here. I'm not using command method, I don't know why some issues are going on. Now you need to spool. So let us say 500 spoon. Now let us say, you have to calculate now. Calculate means how the back of the elbow should have a clear gap from the edge of the edge of the outer edge of the equipment. Now it can be the saddle support, which one is outer, okay, or it can be the dia of the cylinder. So in my scenario right now I have a dia, so I just measure the back of the pipe. So from here, consider a P point, and then from the edge of this consider this P point. So I can say that right now how much is the difference. So it's 2.2 meter only, okay, it's 2.2 meter only. So I need to make a clear space of 150 mm. So I just move by south 150 and WRT slash star enter, right? And then I will create one more elbow. So one more elbow I am going to create here, 90-degree, create, and then you need to rotate the direction towards south. Rotated. Now bring it to the grade level. Okay, so bring it to the grade level means again give a spool of, let us say, 1500. So now bring it to the grade level means always remember the bottom of the pipe, bottom of the elbow should be 600 above the grade level. Okay, so 600 above the grade level. So I need to check QLBOP, leave bottom of pipe. So right now it's 668, so I will lower down this by down 68.15 and WRT slash star enter. And then I need to put the this flange and everything at the grade level. So I just type next connect, right? So next connect, next connect, next connect, next connect, next connect. Oops, 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 sorry. So I just go, okay, so what I need to do is connect backward connect through ID at the rate, and just click on this elbow. Yeah. So what I did is I just bring my wall at the grade level. Let me type forward. Okay, if you want to understand, or if you want to learn the command methods, just give me a message in the comment box. Yeah, I will try to make some videos on the command methods also. So direction, but before that I need to make it backward and dir towards north. Yeah. Okay, and then forward. Okay, so after this flange I need to create a elbow. So let me create an elbow. So create elbow 90-degree. Okay, create, and then it should be direction up this word this time. Okay, now again understand here every piping needs a proper supporting. So I also have to consider, sorry, I also have to consider supporting. So I need to give a space, between the flange and the elbow. So let us give a space, as I already mentioned in my previous classes, like whenever you have a non-insulated line, maintain a 300 gap for a supporting. If you have an insulated line, maintain a 500 gap. So right now I don't have any insulation, I'm just giving 300 spool. Then again elbow, and then click on it, then rotate it towards the south direction through ID cursor and click on this elbow. Okay, oh, there is something is missing here. So let me see what is missing. Now go to, oh, okay, so what is happening, you need to select the element and start, then this one, and then this one. So yeah, okay, so this is how you're gonna route it. Okay, again one supporting is here, then again you will have a supporting, maybe you can put a support here as a holding support or something, then you will have a rest support here, then you will have a rest or guide, whatever support you wanted, you can have a support here, you have a rest support here, you have a rest support here. So now, if it is a non-critical line, then you have a common philosophy, rest guide, rest guide. So in that way only I'm saying. Right, so this is another way. Again, you are maintaining a headroom clearance, people can walk under this. Now if you want to, like, if you don't want to consume this much space, then you can rotate here and then you can move the piping. So I will show you in a better way. Just double click on it. Okay, then press the control button. Okay, and then press this, and then try to rotate the whole piping towards you. so in the west direction, so it will not consume more space. Okay, and then you need to rotate this elbow. You need to rotate this elbow towards the direction south, so dir south, and then you can bring back whole arrangement to this side. So next through C, yeah, next through C, next to C, and next to C. So this is how compatible routing is done, compact routing, sorry, right? So this is how you're gonna route a line in the pipe rack, correct? So as I already told you, like there is a calculation and there is a placement arrangement of the line, and then the future space you need to consider in the pipe rack. So future space is like the total width of the pipe rack. 25% of that total width has to be considered as a future space. So right now I consider a 6 meters length width of the pipe rack. So 25% of that 6 meter, right? So q for example, q 6000 divided by 4, so 1500 mm. 1500 mm, a box has to be maintained here, a 1500 mm box. So let me show you how to, just for your information, or so that the piping, or so that someone else should not occupy this space. So for that purpose we have to make a box here. So new box, copy previous, enter, and the width means the y length. So y length should be 1500, and the x length will be your x length will be your 16,000, and the z length will be your 300, and enter. So you need to make a box like this, and then by east 8000 wrt slash star, enter. So yeah, this is how you're gonna make a box. Okay, just a second, by up 150 wrt slash star. So this is how you're going to make a box in the whole pipe rack, so that no one else should occupy this space. Okay, it will be as an obstruction in the pipe rack, so no one should route their pipe, or nothing should be done here, because it is for future expansion. So this is one way of routing a pipe, sorry, second way of routing, second or third way of routing, right? Okay, now sometimes what will happen, you will have another pipe, you will have another pipe. So let me make another pipe. So for that purpose what I'm going to do is, let me where is my equipment? Yep, not this one, this one, no, this one. So inside it I have one more nozzle, so let me copy the same nozzle. So new nos, copy previous, by east 500 wrt slash star, enter. So I have one more nozzle. Okay, and I just copy the same pipe. So new pipe, copy previous, by east 500 wrt slash star, enter. Okay, so I have another pipe, just type q name, and the name given for this also is 1501. Yeah, same name, everything is done. Now what you need to do is just click on this pipe, go here and click on this, so it will select, it's not selecting. Okay, so be on this pipe, go to piping, modify component. Okay, let's wait for this to get active. What is happening? Nothing is happening, just cancel this one then, and then go to pipe, modify pipe. Okay, so I have my pipe here. Okay, it doesn't have any branch, so you can give a branch name also, copy the pipe name and slash b1. Okay, let me do that also for you. So q name, and then click on the branch, and then just type slash b1 is the branch one, correct? And then you can go to the pipe, select on the pipe, so you will have a pipe here, b1 branch is here, branch head, click on the arrow and click on this nozzle, so the head is connected to this. Okay, now what happens, suppose this is the pipe. Now what you need to do is the next pipe, so then you have to go to the pipe data pro. So inside the pipe data pro there are four things are there, like is safe pipe spacing, safe pipe spacing with insulation, safe flanged pipe spacing, and safe flanged pipe spacing with insulation. So in this scenario, particular scenario, I have a pipe without insulation, without flange. Okay, so let us say 2 inch, 2 inch. This is also 150 rating. Safe gap always we maintain 50 mm, and the distance between the pipe to pipe is this. So between 2 inch pipe and 2 inch pipe, the safe distance is 83 mm, and I want to provide a safe gap of 50 mm and then calculate. So it's 110, but I don't have a license version, so it is showing only for 2 inch, but here it's 4 inch. So let us assume 200 mm is the center to center distance. So what I'm going to do here is I just click on this elbow. Okay, I just click on this elbow and then go to the command line and then by south 200 wrt slash star enter, and then I will say next through C, next through C, and then branch connection pipe tail to last member. Where is that command? Yeah, this one. Right, now what you need to do is just check, just for your assurity, just check measure element snap, this one and this one. Is it 200 mm? Yeah, that's 200 mm. But the important thing that you need to check is the safe gap. Okay, always remember to check the safe gap. So this corner till this corner, oops, sorry. So what is the gap? It's 86. So what you need to maintain is 50 mm. So eventually you have to maintain a 50 mm gap. Okay, so that you can maintain. So 36 mm you can shift it to this side. That you can do later by yourself. Just I'm talking about how to give the spacing. So that's, this is for the piping with a without insulation, without flange. Now let us assume we have one more piping. Let us assume we have one more piping, and that piping is like a with a flange. So one is piping and one is with a flange. Or okay, or now let's suppose we have two flanges. We have two flanges. So first of all, always remember that in the pipe rack we don't put any flanged item. We don't put any flanged item. Very rarely you will get a orifice flow meter. Okay, orifice, because you need to maintain a straight pipe piece na? So that's why we sometimes we put orifice. So always remember, if you are putting a orifice or if you are putting a wall in the pipe rack, see, pipe rack has two things. One is the end of the pipe rack and one is in the pipe rack. Okay, so if you have any wall in the pipe rack, let us assume you have a wall on this blue line, on this blue line, you have a wall on this blue line, because you don't have any other option, you need to put a wall on this blue line. So let me put a wall on this blue line. Yes, so let me put a wall here and then we will see what will happen. Okay, so after this elbow, go to create component. Yeah, and then click on the flange, create. Okay, then give a spool of, let us say 500, then gasket, then wall, gate wall, then again gasket, and then again flange. Right, okay. So if you have a scenario like this, so what you can do is never place in this type of walls at the center. Okay, or center means you always have to place these kind of walls at the corner. At the corner means here, at the corner, or should be at the corner most to the column. Okay, or next to the column, so that the person can put a ladder here. Okay, temporary ladder or stool, and he can access the wall. Because as you know that if you have any component which is flanged, you need to provide access to that. So valve is what? It's a flanged component. You need to provide access. Valve has a hand wheel. You need to provide method for operations, right? So if you have a valve in a pipe rack, make sure that it is accessible. So how to accessible? It has to be at the corner, or it has to be next to the column, so that the person can put his ladder here, temporary ladder on this member, and he can operate, right? So this is what you can do. Now sometimes what happen, let us say there is another wall here. There is another wall here. So let me create a wall. Okay, so let's say flange. This is well neck flange. Then you have a gasket. Okay, so but okay, let's say gasket, create. Then you have a wall, that is your gate wall. Okay, and then you have a gasket again. Okay, then you have a gasket, and then you have a flange, well neck flange, right? Okay, this is the scenario. Then what you need to do, never place. Okay, people what they do is, as I told you, like, okay, you need to provide a ladder for the operation of and all those things. So sometimes the designer, what they do is, they just make like this. I will show you. They will make like this, just exactly parallel to it. So never make this mistake, like you cannot put all the walls, the center line of the wall should be matching with the other wall center line. No, you can't do like this. You always have to stagger it. You always have to what? Stagger it. Stagger it means it should be like this. So this is called staggering of the flanges. So you always have to what? Stagger it. Or suppose you have a two walls, so what you need to do is, you have to stagger it in this way, so that the person can put a ladder here in between these two flanges, and then you need to rotate the handle of this wall at a 45-degree angle, at a 45-degree angle. Okay, you cannot rotate any wall handle on the basis by your own. Like, you have to calculate first how much we can rotate, and then only you can rotate the wall handle. So how to calculate that, at what angle you are going to rotate the wall? Either it can be 30-degree, it can be 45-degree, right? Or it can be little bit further more down. So how to calculate how much is the rotation? You have to calculate the number of bolts. You have to calculate the number of bolts. So let us go to the flange. Okay, and just take a well neck flange, right? This is your well neck flange. I'm taking for 2 inch. So how many holes are here? So there are 4 holes. So a 2-inch gate wall, if you want to rotate the handle of the 2-inch gate wall, what you need to do is 360 divided by 4, so that is 90. So this handle can be rotated by 90-degree only. You cannot rotate by 45-degree, you cannot rotate by 30-degree, you cannot rotate by 60-degree. So always, whenever you are turning the hand wheel to at any angle, first calculate the number of bolts. Okay, you can get it from the Pipe Data Pro. You can get it from the Pipe Data Pro. This is bolt holes. So 360 divided by number of bolt holes, you will get an angle, at what angle you can rotate it. So another point that you need to understand here is the staggering of the wall. Okay, staggering of the wall or any flange component. Okay, now sometimes what happen, I miss mostly whenever we are putting a wall, or there's a situation to put a wall in the pipe rack, which wall you can put it. So you can put a wall, this one. So again, flange. Flange, then you have a spool, or let us say 500 mm. This is too much. Let us say 300 mm. 300 mm. Then you have a gasket. Then you have a wall. Okay, so this is my wall, and then you have another gasket, and then you have a flange. So which wall you can put in the pipe rack? That is your check wall, because check wall does not require any maintenance. But the same thing happen if you have two check walls in both the pipes and which is next to each other, then you have to maintain a staggering. Another thing that you need to understand here is, see, the weld is coming exactly on the member top, so you cannot put your check wall here, so you have to move it. You have to move it. Okay, so you have to move it at any other direction, whichever direction you want it. First, please maintain the flow. Okay, so this is how you are gonna place your check wall, right? And you will get a support here also. So no weld should rest on the member. So this is one more thing that you need to consider in the pipe rack. Correct. Now there is one more thing that you also need to consider, that this is the first tier. This is the first tier of the pipe rack, that is called as process tier. The second tier is called as utility, and the third is called as the flare. Understood? Now, for example, uh, now yes, now you have a now let us create one more pipe. Okay, let's take this pipe only. Now I want to, this blue pipe has to go outside of the pipe rack. So how to go outside of the pipe rack, that also you need to understand. Correct. So same intermediate member is also required here. So just double click on this. Okay, I'm just creating one more member, right? So go to the command window and then a new box, copy previous by south 6 meter, because the width of the pipe I consider as 6 meter, and enter. So another box is created there. Press escape. Okay, and now coming back to my pipe. This is my pipe, so I will just click on the last flange. Okay, so this is my flange, right? Flange gasket wall. Which pipe is selected? Oh, it's selecting this pipe. Yeah. Okay, let's take this pipe only. So after this flange, I am going to create how to go outside right now. Okay, so I am going to create an elbow. Okay, so elbow 90-degree, creating elbow. Now the direction of this one is up. Okay, now through ID cursor, I'm just going to click on this particular thing, elbow. So see, but this elbow is coming exactly here, so I'm not going exactly at the edge of the member. So by west, let us say 1 meter, wrt slash star, and then I am going to create one more elbow. So elbow, elbow 90, create, and then I need to rotate this elbow towards south direction. So I just rotated it to south. Okay, rotate it to south, and then through ID cursor, click on this elbow. Is it correct or not? I need to check one more time. So yeah, it's graphic cursor, so always remember element snap. Yeah, now it's corrected. Okay, now again create one more elbow, elbow 90-degree, click on this, direction has to be down. Correct. Now again you have to maintain the same 300 mm back of pipe. So this time I need to calculate a little bit. So center here, I'm just taking a random value, you guys can calculate by yourself. Okay, but always make sure that you have to maintain a 300 mm of back of pipe. So by south, let me take as 400, wrt slash star, enter, and then I am going to create one more elbow. So elbow, and then I am going to create elbow. Then you need to rotate this elbow towards south direction. Yeah, and then through ID cursor, I need to maintain a BOP. Correct. So just click on this, right, and then again I need to create one more elbow. So let me create an elbow, elbow 90. Okay, then this has to go towards the nozzle, and then one more elbow. Yeah, 90-degree elbow, connect. Then this has to go to direction down through ID cursor and click on the nozzle. So it will come exactly at the top, and I already have a flange at the last, so I just say next connect. So my flange come here, and then I just create one more gasket, 150 rating, create, and then I need to go to my branch. Okay, I need to go to my branch P1, and then I need to select the branch T or tail, and then this, click on this, so it's connected. Go to the gasket, go to the command window, type backward CONN space NEXCONN, then FOR. So my pipe is connected with the nozzle. So this is how you're gonna take out your line outside the pipe rack. Okay, so always remember you have to maintain this what to say, intermediate member. You have to calculate the height of the intermediate member, and then you have to take your lines taking support from the intermediate member. The same thing happens in the utility line, flare line, wherever you are, right? So this is how you're gonna route your lines in the pipe rack. Okay, now one more thing is that this assembly, either you can place it here, or this assembly you can place it under the or at the corner of this. Here you can place it. Okay, so in this part also you can place these assemblies. So it depends on your availability of space and all. If you have more space here, you have a walkway here, so it depends on that, right? So this is how you're gonna do it. Now similarly you have this is the battery limit. Okay, this is what, this is the battery limit. So whenever you have a battery limit now, so always remember in the battery limit you have flanges, so like for example, if you have this pipe, let me say that click on this branch, and I will say new branch, copy previous by south, and let me say, okay, now what is the pipe spacing between the flanges? So go to pipe spacing of 2 inch, and this time I have a pipe safe flanged pipe spacing. Both are 150 150, 2 inch 2 inch, so it will says 157, right? So let me consider, now this time I am going to consider uh, 350 or 300, let us say 300. So branch by south 300, WRT slash star enter. So now this is my, so always remember whenever do you have a battery limit arrangement now, so always make sure that these flanges should also be staggered. These flanges should also be staggered. That's why we are extending this thing till here. A 300 mm spool we are giving, so you have to move this one little bit back. So by west, let us say 150 WRT, like this, but make sure that from the edge of this column to the edge of this should be a clear gap of 1D spool. Okay, so flange, and then you have to say branch connection pipe tail to last member, right? And suppose you have copied the same pipe again, so again you copied, and then this time this one has to be like this, through id at the rate enter, and then click here. So it will be like a staggering form. So in this form you have to arrange your pipes at the battery limits, correct? So this is how you're gonna arrange your pipe rack, piping in the pipe rack, correct? Now similarly, if your line is going to the top tier, for example, if I'm going to consider the same green line, this one, so let me backward through id at the rate, and then uh, bac through id at the rate, and this time I'm going to consider this one, and then I will say next through c. Okay, so this is somewhat this is going to be happen. Okay, so double click on this one more time, so that the model editor will activate. Okay, and then I will take this thing, right click, align with feature, and then take this one point. So yeah, so this is how our pipe is going to be routed in the top section. double click on it, select this one and bring it little bit up. Okay, I'm not just measuring here right now, or do you want me to measure? So it's 43 mm. So let me go to the command section, forward, by down 43, next through C. Yeah. Okay, now let us say there is an insulation in this pipe. For example, if there is an insulation in this pipe, then the bottom of this pipe will be 100 mm above the steel section, 100 mm above this one. So then at that time you have to raise this pipe by 100 mm, right, like this. So if you have an insulation, the pipe BOP is 100 mm above the top of the steel, so that you need to maintain, okay, if the line is insulated. So this is how you're gonna route your piping. Okay, the advantage, sorry, the purpose of creating these intermediate members, and the purpose of creating this staggering and all, the purpose when you are going to, what type of walls you can use in the pipe rack, it doesn't require any maintenance. And if you have any wall which require maintenance, that has to be at the corner, so that the person can put a temporary ladder and can use it. Okay, then headroom clearance, wall assembly either next to the equipment or under the pipe rack. So that all you need to consider as per your layout requirement. And then the another thing is that you need to keep a empty space. So let me make that also. If I go to this box, if I go to this box and I will say new box, copy previous, new box, copy previous by down 2 meter, WRT slash enter, and I've just changed the parametric value of this is like Y length I will consider 3 meter, then Z length I will consider 4 meter, right? So this is how it is going to be. So this box is created for the purpose of what? For the purpose of hydra movement. So you need to create a box under the pipe rack so that no one should block this space, because it is for the hydra movement. So this is all about your piping in the pipe rack. I hope you guys like this video, or it will be informative for you guys. If you have any doubt, please let me know in the comment box. I will try to clear your queries. Thank you so much. Till then, bye bye.